Good evening, everyone, and welcome to another exciting program that we're bringing live to your homes this evening. We're so excited to have you all. My name is Jessica Williams, Programs and Community Partnerships Manager at Chabot Space and Science Center, and we are thrilled to be with you tonight. Thanks for tuning in, everyone. Tonight we have with us Ben Burress, who will be talking with us about how visions of sci-fi have led way to space. But first, I'd like to give a shout out to all of the Chabot members and donors out there. You can join our community of science supporters by becoming a member at Chabot Space and Science Center through December 31st. Just a moment. Having some feedback there. Sorry. So through December 31st, when you buy a membership, Chabot will give a membership to a local teacher. Click the link in the description and learn more. Before we get started, please consider making a donation to help us make these programs possible. These free events are fueled by you, our community, and thanks to you, we have been able to offer more than 75 free STEM events since April. Right now, we need your help to create STEM learning opportunities for our community at home. In less than a minute, you can make a difference by donating here on Facebook or at chabotspace.org. And now I would like to introduce to you Ben Burress. Hi, Ben.
Hi, how are you tonight?
Doing good. So happy to have you. Ben has been a staff astronomer here at Chabot Space and Science Center since July 1999. He graduated from Sonoma State University in 1985 with a bachelor's degree in physics and a minor in astronomy, after which he signed on for a 2-year stint in the Peace Corps, where he taught physics and mathematics in the African nation of Cameroon. From 1989 to 1996, he served on the crew of NASA's Kuiper Airborne Observatory at NASA Ames Research Center in Mountain View, California. From 1996 to 1999, he was head observer at the Naval Prototype Optical Interferometer Program at Lowell Observatory in Flagstaff, Arizona. He has also been a regular science writing contributor to the KQED website since 2005. Thank you, Ben, for joining us. Take it away.
Thanks, Jessica. Glad to be here. Hello, everyone. So, anyone out there want to go to the moon? My grandfather used to ask me this question quite a bit, actually, and my usual answer to him was yes, of course. After all, I was born the year after the first humans traveled into space, and my youthful imagination was shaped by astronauts, the Mercury and Gemini missions, and of course the Apollo moon landings. I wonder what Grandpa thought of me and my passion to travel in space. He was born in 1903, the year the Wright brothers made their first flight. So his youthful adventurousness was shaped by a very different story. But I know my imagination was shaped by more than the actual stories of space exploration. The imaginative stories of science fiction played their part too, in a big way. Science is the thinking part of space exploration, but science fiction is the imagining part. As far as I'm concerned, it takes both to get us there at all. Give me a second here. I want to find the button to share my screen, if it will come back. This is live after all, so here we go. Found it. And let's get that framed up here. All right. Let's take it away. Science fiction has been called the literature of ideas, though some of its incarnations border on or cross fully into the realm of the silly or unlikely. I'm sure you know at least a few of these. Its long tradition of speculating on the possibilities of reality and the future makes it some of the best food for thought you can pull off the pantry shelf or bookshelf. Take your pick. The themes explored by science fiction often seem far removed from our everyday experience, but we can still find them just as captivating as any important real issues or situations in our lives. The big ideas around science fiction often center around advanced science and technology, space exploration, time travel, one of my favorites, parallel universes. Look carefully in the reflection there and you'll see what I'm talking about. And who can forget extraterrestrial life? Though the term science fiction as a literary genre wasn't coined until the 20th century, the first science fiction novels and stories were written well before this. Jules Verne cranked out many in the mid to late 19th century. His work was predated by Mary Shelley's 1818 novel Frankenstein, of course. But two centuries before Frankenstein appeared a story called The Chemical Wedding, which, by the way, I'll be transparent, I have not read, but I'm going to look for it now. Anyway, some have called The Chemical Wedding the first actual science fiction novel of all time. I have another story for you to consider. Let me tell you the tale of another legend, the legend of Wan Hu. You can decide if it fits the bill of first science fiction tale after you hear it. So, as the legend goes, Wan Hu is a legendary Chinese Ming Dynasty official and stargazer with a dream of reaching the stars. He is said to have built a structure supporting a chair and 47 small rockets. Dressed splendidly for the occasion, Wan Hu seated himself in the chair and was attended by 47 servants who simultaneously lit the 47 rockets and then stood far back. There followed an explosion. When the smoke cleared, Wan Hu and his chair were nowhere to be found. Did he make it? Whether he did or not, centuries later, Yang Liwei became the first confirmed Chinese national to fly in outer space on a Chinese spacecraft, Shenzhou 5. Liwei was propelled by rocket technology originally invented in ancient China and maybe concept tested by Wan Hu. We can't know. NASA named an impact crater on the moon after Wan Hu. And by the way, there's no evidence to suggest that Wan Hu created this crater. Probably the greatest physical obstacle to space travel is the Earth's gravity. The same thing that makes it so valuable to us, keeping us safely bound to the ground in our life-giving environment, also imposes a barrier to going other places that was only overcome about 60 years ago. It's often assumed that if you can just get off the Earth's surface, you're suddenly beyond its gravitational pull and free to travel in space wherever you want. It's an understandable assumption, seeing how astronauts on the International Space Station float weightlessly, apparently free of Earth's gravity. But even at the elevation of the ISS, about 200 miles up, Earth exerts a strong gravitational pull downward, about 90% the strength it is on the ground. Earth's gravity can be visualized as a deep pit or well that gets shallower the farther you are from it, but never ends. It just gets weaker. Most of the work of escaping from this gravitational well is done very close to the Earth. And once the steepest part of the pit is overcome, escaping farther into space becomes easier and easier. Without sufficient speed, however, an object will eventually slow down and then fall back to the Earth. Douglas Adams described the ability of a human to fly as falling at the Earth and missing. And though his Hitchhiker's Guide novel series made full-body plunges into the realm of the ridiculous, and very entertaining, by the way, this tongue-in-cheek explanation doesn't fall very far from the mark of reality, sort of. Let me explain. Almost 300 years before Douglas Adams, Sir Isaac Newton came up with a thought experiment, or science fiction short story, to describe how an object may perpetually fly within the Earth's gravitational field. He described placing a really big cannon on top of a really tall mountain, both of ludicrous proportions, and firing a cannonball directly toward the horizon. At ordinary velocities, the cannonball would naturally fall in a curving arc toward the Earth's surface, pulled down by gravity, to hit the ground some distance away from the mountain. With faster muzzle velocity, the cannonball would, of course, travel farther before being pulled to the ground. At just the right velocity, Newton argued, the downward falling curve of the cannonball's path would match the curve of the Earth's round surface and would perpetually fall around the Earth in an orbit. Today, thousands of artificial satellites follow where Newton's thoughts went 3 centuries ago. Top-notch sci-fi thinker there, Isaac. Sir Isaac, I should say. It's kind of fun to think of the gravity wells of all the objects in the solar system as valleys or pits, separated by peaks or ridges between, like the topography of the landscape. As challenging as it is to escape Earth's gravity well, which requires a breakaway speed or escape velocity of 25,000 miles per hour in order to coast perpetually into space, future destinations like Jupiter and Saturn are much larger traps, and anyone who ventures into their wells must plan carefully how they will get out when they want to come home. Thinking about gravity in this way and taking into consideration the sun's own enormous gravity pit that encompasses the entire solar system can give you ideas of what it means to travel and maneuver from one planet to another. Outward is uphill, inward falls into a deep pit. Jules Verne broke free of Earth's gravity well and reached the moon, at least in fiction, over a century before NASA sent astronauts there. His post-US Civil War novel, From the Earth to the Moon, laid out a very detailed plan for how to achieve this, and shows us that people thought about humans traveling to the moon as far back as the middle of the 19th century, and even further back in more whimsical, less sci-techy tales of fantasy. What's striking about From the Earth to the Moon are elements of the story that almost seem to foresee actual events of the Apollo missions, not the least of which is its post-war setting and the spirit of competition and rivalry that propelled it. In this case, it was a rivalry between two men, not global superpowers. So what are those similarities? One, the launch site that Jules Verne chose near Tampa Bay, Florida, is only 130 miles from Cape Canaveral, where the Apollo launches took place. Coincidental? Probably. And though Verne did a lot of research on his story, he never actually visited Florida, stating that his launch site, which he pegged to exact geographic coordinates, was at an elevation of 1,800 feet. The spot in question is actually at sea level, and in fact, nothing in Florida is much higher than 300 feet. Jules Verne's space capsule was patterned after a cannon projectile, appropriate since it was to be launched to the moon by a giant cannon, and was designed by a club of post-war gun enthusiasts. And let's face it, the Apollo Command and Service Module is shaped a bit like a cannon projectile also. Jules Verne's launch device was a gargantuan cannon that fired the capsule upward. NASA's method was essentially a gargantuan cannon attached to the capsule that fired downward. If you want to stretch the definition a bit. Jules Verne's crew consisted of 3 men, including one Frenchman, making his pre-space age fictional voyage the first international cooperative space venture. Jules Verne was French, of course, so how could he resist? The capsule also carried a pair of dogs and several chickens to provide the voyagers with fresh eggs. Only in the last decade or so have experiments been done to grow food on the ISS. Apollo 11 consisted of 3 men as well, but no livestock. Both moon landings were accomplished for more than one reason, including scientific exploration and political one-upmanship, or three-upmanship in this case. Jules Verne's lunar achievements, while well-researched and engineered with no precedents to work with, didn't solve every problem of sending people to the moon. For one, a much longer cannon barrel would be needed to launch the capsule gently enough not to squash its human occupants. But the story laid out the technical steps of a plausible moonshot, letting people glimpse a realistic way for how it could be done. Who can say it didn't influence the thinking of the engineers who a century later made real what Jules Verne imagined? By the way, From the Earth to the Moon was turned into a movie. Did you know? Did you see it? Maybe not. This was Georges Méliès's 1902 silent film, A Trip to the Moon, based loosely on Verne's novel, but with a good deal more theatrics. Less than 4 decades after Jules Verne blasted his astronaut crew to the moon in a violent explosion of cannon fire, H.G. Wells envisioned a gentler mode of travel to escape Earth's gravity and navigate between worlds. To do this, he had to invent a fictional substance called cavorite, after its fictional inventor, Dr. Cavor. In Wells's story, cavorite acts like a shield against gravity and can render a spacecraft weightless and able to navigate between worlds, similar to how a sailboat tacks in the wind. Though modern science has not conceived of a substance with the properties of cavorite, Wells's stretching of his imagination to envision a novel mode of propulsion for space travel may have helped widen the thought horizons of scientists and engineers to do the same. One way engineers have devised to cruise space without conventional rockets is electric ion propulsion. What you can think of as an electric rocket was tested on NASA's Deep Space One probe in 1998, which allowed the spacecraft to visit two different objects in space, the asteroid Braille and the comet Borrelly. The same style of propulsion was used on NASA's Dawn spacecraft between 2007 and 2018, which traveled to and orbited the asteroid Vesta in 2014 and the dwarf planet Ceres in 2015. Conventional rockets combust fuel and harness the released energy in a controlled explosion to produce thrust. An ion engine uses electric and magnetic fields to accelerate and channel electrically charged particles, or ions, and send them out as a beam of high-speed plasma. Deep Space One and Dawn use the element xenon for propellant, since the heavier atomic nuclei provides a stronger kick of momentum, and liquid xenon can be stably stored. The ion engine's punch isn't quite like a chemical rocket's. Their low thrust can only accelerate their spacecraft from 0 to 60 miles per hour in 4 days. But unlike the chemical rocket, the ion engine is 7 to 10 times more fuel efficient than chemical rockets and can run continually for long periods. It's this efficiency and this slow and steady style of propulsion that allowed both spacecraft to travel to and orbit a target object and then move on to another. Maybe best of all, the energy to power this ion engine can be generated with solar panels. And though Scotty was very impressed by alien ion engine technology when he encountered it, that just means that NASA achieved the real thing 2 centuries before its invention in science fiction, ahead of the game for a change. Powerful cannons, rockets, and futuristic ion propulsion drives are really great, but perhaps one of the most effective and innovative methods of interplanetary and even interstellar travel has been the gravity assist. Using a planet's gravity to tap the enormous reservoirs of a planet's momentum to maneuver, accelerate, and decelerate a comparatively tiny spacecraft enables visits to multiple planets, again without the use of conventional rockets. For example, the spacecraft Messenger got all the way to Mercury by making course and speed adjustments using the gravity of Earth, Venus, and Mercury. Making a close flyby of Earth and 2 by Venus, Messenger maneuvered deep into the inner solar system, into Mercury's realm. Then, with 3 flybys of Mercury itself, Messenger slowed down enough to use its small rocket engine to settle into orbit around Mercury. The trip took 7 years, saved a huge amount of fuel that the tiny Messenger would otherwise have had to carry along with it. Messenger was not the first mission to perform gravitational-assisted maneuvers. The Soviet Luna 3 used the moon's gravity to get to the far side of the moon. Pioneers 10 and 11, Mariner 10, Voyagers 1 and 2, Galileo, Ulysses, Cassini, Rosetta, Juno, the Parker Solar Probe, and Bepi Colombo, to name a few, are other spacecraft that have traveled far and wide by tacking through the gravitational fields of planets. I think Dr. Cavor would have been impressed. The most impressive feat of any spacecraft sailing by gravity is that of Voyager 2, which not only used the technique to visit all 4 gas giant planets, Jupiter, Saturn, Uranus, and Neptune, but also acquired enough momentum from these encounters to achieve solar escape velocity, the speed necessary to escape the sun's deep and expansive gravity well and coast perpetually away. Voyager 2, along with Voyager 1, the two pioneers, 10 and 11, and New Horizons, are currently outbound from the solar system, never to return. Voyagers 1 and 2, now about 3 times farther away than Pluto, have officially crossed over the boundary of the sun's heliopause and entered interstellar space. So as a spacefaring people, we have gone interstellar officially. Yes. The creators of science fiction tales attempt to show us visions of what someday may come, letting us at least glimpse possibilities of a future that has not yet arrived and may never. But perhaps the exercise it gives our imaginations can prepare us for things that might yet happen in one form or another. The Flash Gordon serials of the 1930s may be campy, low-budget, often laughable escapades of the ridiculous, but they helped conjure a picture of travel to other planets using a form of propulsion that was known mostly for its applications in entertainment and warfare, rockets. And more, here was a story featuring a rocket-powered spacecraft instrumental in saving the Earth and the universe time and time again. Amusingly, in this time before jet engine aircraft, the sound effects department for Flash Gordon chose the droning of airplane propellers to Foley the sound for Dr. Zarkov's rocket ship. Even more amusing, flash forward about 50 years and you will find Star Wars using anything but rockets and jets for their spacecraft noises, some even sounding a little bit like Dr. Zarkov's engine. Sometime around the 1960s, the achievements of science and space exploration began to catch up with the visions of science fiction. The first humans traveled into space in Vostok and Mercury capsules at the beginning of the decade, and were followed a year or two later by the first robotic voyages to other planets, Venus by Mariner 2, and Mars by Mariner 4. The actual space age, not its science fiction precursor, had begun. Not to be outdone by reality, in 1966, the Starship Enterprise pushed the envelope of imagination to interstellar proportions, exploring dozens of strange new worlds orbiting other stars. Fictitious worlds, yes, but this was in a time when no planets were known to exist outside our own solar system, so they had to be imagined in order to tell captivating tales. Not to be outdone by a fictional television space cowboy series like Star Trek, actual scientists began to find actual extrasolar planets starting in 1992. They found them spread across the same light years of territory explored by the Enterprise 3 decades before. To date, astronomers have confirmed the existence of over 4,000 exoplanets in almost as many star systems in the Milky Way galaxy. And based on these samplings, scientists have made an astonishing projection. When it comes to Earth-sized planets orbiting within their star's habitable zones, where the temperature is right for the possibility of liquid water to exist, there may be as many as 6 billion Earth-like planets in the Milky Way. 6 billion with a B. Some estimates range higher, to as high as 40 billion. And that's planets that could be like Earth, could possess liquid water, and could nurture environments friendly to some form of life. That, to me, is a discovery of science that far exceeds the wildest imaginings of science fiction, and it's based on observation and math. Moving along. NASA's Space Shuttle program, which first launched in 1981, is another fun example of how a vision of sci-fi worked its way into reality. And this time, reality got there first. The 1968 film 2001: A Space Odyssey, based on Arthur C. Clarke's 1951 novel, The Sentinel, depicted regular passenger travel into space on sleek airliner-like spacecraft. But that's not all. The film also introduced the involvement in space travel by commercial corporations, in this case, Pan Am. Too bad Pan Am didn't actually survive, but science fiction can't predict everything accurately. Space Odyssey also depicted a large space station in construction in 2001. Construction of the ISS that we know was mostly completed by 1998, only 3 years under the wire. Visions of science fiction speculating on the possibility of space travel preceded the space age by decades at least. The inventions and narratives of sci-fi have sometimes influenced, or at least prepared us for, actual ventures into space. What future space adventures await us and humanity? And how many science fiction, new and old, how may science fiction, new and old, enable us to travel the road to the stars? Time for some curtains. Get ready. It's 600 feet long, almost twice the length of a Saturn V rocket. Click, thank you. It weighs 6 million pounds. It carries 100 million pounds of fuel. And its nuclear pulse engines, the nuclear pulse engines in its 2 stages, have a total burn time of about 4 years. Are we talking about a ship to whisk a human crew to a distant star, to plant a flag in the soil of some faraway and alien exoplanet? Not exactly. Project Daedalus is a 1970s engineering concept for an actual robotic interstellar probe. No humans aboard. And though we have not yet overcome all of the technical challenges that would make it actually work, Daedalus is considered a foundational baseline concept for possible future interstellar missions. And here's how it goes. After expending the fuel in both of its stages and accelerating to 12% the speed of light, Daedalus would cruise for the next 46 years to reach one of the nearest stars to our sun, Barnard's star. Then, without fuel to slow down, it would cruise all the way through that star system in a mere 70 hours, and then coast on into the reaches of the Milky Way galaxy, forever drifting through space. So after 46 years of travel, 70 hours of quick flyby pictures, and it's over. And that's a robotic probe, so yeah. But we'd get there, right? But how do we get there ourselves? It would be nice not to have to spend decades or centuries cooped up in a spaceship. Freezing the crew for the voyage and thawing them out at the other end is a favorite gimmick for interstellar human travel in fiction. It's a real win-win. You don't age, and you don't get bored traveling between the stars. If only we could solve the problem of freezer burn. I have a question for you. If you could be frozen safely for a voyage to another star, would you do it? Think about it. You would go to sleep knowing that you would never again see your family and friends, unless, of course, they came along with you. There would be no possibility of returning home to Earth, ever, at least in the first voyages. You would wake up tens or possibly hundreds of years in the future, in an alien star system, maybe on a completely alien planet. And you might be thawed out before reaching your destination to investigate the crash of an alien spaceship infested with xenomorphs. Now you decide. Better than being frozen, maybe, is to get to other stars faster. Warp drive was introduced into science fiction by John W. Campbell in his 1957 novel, Island in Space. The concept was exploited by the writers of Star Trek in 1966 to move TV episodes along at a speedy weekly clip. The idea of warp drive is to get around Einstein's universal speed limit, the speed of light, 186,300 miles per second, by warping the space around a ship, compressing the fabric of space in front of it and expanding it behind. This would produce a wave of warped space that would move the ship forward at effective faster than light speeds, but without the ship ever exceeding the speed of light relative to the bubble of warped space around it, and so evading the speeding ticket from Einstein on a technicality. Think of a surfer riding along on a wave of water, possibly very fast relative to the shoreline, but not relative to the water around them. Is warp drive science fiction pie in the sky? Miguel Alcubierre conceptualized a theoretical warp drive in 1994 that is consistent with Einstein's equations of general relativity. To function, the Alcubierre drive would need to create a region of space with negative energy density, or less energy than exists in a pure vacuum. For this concept to ever be realized would require the existence of a form of exotic matter with particular properties. If such exotic matter does not exist or cannot exist, then the Alcubierre drive cannot be realized. Now, what do we have behind the curtain here? Ta-da! Wait, a real Starship Enterprise with a real warp drive? Well, not yet. What you're looking at is a creation of a this century, time warp, 2014 collaboration between NASA scientist Harold White and artist Mark Rademacher, the IXS Enterprise. It's a conceptual starship designed with using a modified version of the Alcubierre warp drive. Based on the theoretical physics and the specifications of this concept starship, the IXS Enterprise would be capable of traveling to the Alpha Centauri system, a distance of 4.3 light years, in about 2 weeks. Imagine the camping trips with one of these parked in your garage. Like the original Alcubierre drive concept, for this one to ever function would require the existence of a particular kind of exotic matter, a type of matter not currently known to exist. But hunting down theoretical exotic forms of matter not currently known to exist is something else scientists do using particle accelerators. So who knows? Science fiction is built on visions of the aspirational, some leading down dark, alien-infested tunnels, some to a brighter future than our present times might let us believe is possible. But think about the centuries of imaginative speculation by individuals who chose to write it down, often as captivating, entertaining tales. Consider how, in time, some of those visions, in one form or another, made their way to the light of reality. Science fiction encourages us to think about the future and imagine its possibilities. How we choose to use our imaginations and what visions we may want to illuminate is up to us. But don't forget, so much of what is today was first imagined by someone in the past. So think about the future. Imagine the possibilities. Tell a story for others to share. In time, a decade, a century, 1,000 years from now, you may be right. Thank you. That is the end of my talk. Unless there are questions, I'm going to hand this back over. Oh, that was the slide I was supposed to end on. Beautiful, huh? Okay. Ending sharing, back in the box.
Thanks, Ben. That was a fascinating talk.
Oh, thanks.
Really interesting. Yeah. Actually, a question did come through that might be, hypothetical, but warp drive. So warp drive through space is appealing in science fiction, but what happens if the ship collides with something while in motion?
Yeah, that would be pretty bad, wouldn't it? Well, I know that Star Trek had its own means of protecting the ship, but that's science fiction, of course. The idea of a real warp drive, the Alcubierre drive that we're showing, is that there would be a wave of warped space inside which the ship is moving at basically zero speed relative to the bubble of space around it. I don't know the physics of what would happen if this bubble with the ship inside came across a particle of dust or whatever. That might be devastating. If it accelerates it into the bubble, or that will require further reading, but that's a very good question. I know if you hit something in your spaceship and you're traveling at realistic speeds, that can be pretty bad too. I know that the space shuttle had a big hole knocked out of it by something like a chip of paint that was orbiting the Earth, but the relative speed was so great that it had a lot of energy, a lot of punch. But yeah, so avoiding obstacles in space would be another technical challenge. But the thought experiment of coming up with an actual working warp drive is just that, it's a thought experiment. But the more reality they put to it, the more possible it becomes. So we'll see. It may never be achievable, but it's no longer just science fiction. You know, it actually has some hard science attached to it. So that's exciting.
Yeah, it's pretty amazing to see the things that we're doing now that were once just in someone's imagination. It's pretty amazing too to see that come to pass. So now, yeah, I'm just curious to see, you know, someone asks, you know, maybe dark matter will help some of these questions we have, or, you know, maybe there's things that we're still learning about that might be able to help propel us in the future a little more to what could be possible.
Right. So imagine that story about dark matter and how it might help us in the future. Maybe it will become reality someday.
Someone says, luckily space is largely empty. We are also quite adept at spotting items from great distances.
Yeah, true. But imagine you're moving along at, you know, over the speed of light, and there's a particle of dust ahead. It would take some pretty good machinery to spot that in advance. But hey, I think anything's possible.
Well, thank you, Ben. I don't know if there's any more questions at this point, but it was a very enjoyable talk, very exciting just to kind of see what's been done in history. I didn't even realize that there was science fiction since 1902. You know, that goes back pretty far. It's pretty neat to see what
even earlier than that, when you take into account like Frankenstein and
right.
Jules Verne and all that, and Wan Hu.
Right. Pretty amazing. I learned a lot. It was really great to sort of see, you know, human imagination is pretty incredible and on how far we've come in reality. So thank you so much for being with us tonight and for giving us this great talk.
Thank you.
And yeah, we'll have to do more of these kinds of talks in the future. It's really great just to sort of see the research. So thank you for doing that research and for presenting that today.
All right. My pleasure. Night, everyone.
I've had a lot of fun learning tonight, and I hope that you all did too. And post something you learned tonight and let us know what you learned in the comments. Coming up, we hope you'll join us tomorrow night and every Saturday night at 9 p.m. for our virtual telescope viewing with our resident astronomers. And coming up on Friday, December 4th, will be our next Friday program for A Jewel in the Sky, spotting the International Space Station with Farid Khalaf. For notifications about our events and more fun science content, like Chabot Space and Science Center on Facebook so you can see what's coming up. Thank you to everyone who tuned in tonight, and a special thanks to our members and donors and partners for helping us bring science to life for everyone at home. Before you head out, please consider donating to help keep these programs free and fun for everyone. And thank you to everyone who donated this evening as well. Right now, we need your help to create STEM learning opportunities for our community at home. If you would like to support Chabot Space and Science Center, you can make a donation here on Facebook or at chabotspace.org. I'm Jessica Williams with Chabot Space and Science Center, and thank you all for tuning in tonight, and we hope to see you soon. Until next time, stay curious. Bye.